All right, let's get right into it. Today, we're cracking the code on one of the most critical tools in any pilot's toolkit, the Terminal Aerodrome Forecast, or TAF. For making smart decisions, both on the ground and in the air, knowing how to read this is absolutely non-negotiable. So you look at something like this for the first time, and yeah, it seems like a total mess of encrypted letters and numbers. It's dense, it's packed with info, and frankly, it looks like a secret code that only a spy could love.
But here's the good news. It's not nearly as intimidating as it looks. Every single part of this forecast has a specific job and a specific place to be. We're going to pull this thing apart piece by piece and show you exactly how it works.
So here's our flight plan for today. We'll start with what a TAF actually is, then we'll look at its anatomy, decode the main elements and those all-important change groups, and then we'll put it all back together to translate a full forecast. By the end of this, you'll be reading these like a second language. Okay, let's dive right into Section 1. Why do we call this thing the pilot's crystal ball? What is its fundamental purpose? So the most important thing to get straight is this. A TAF is not what's happening right now. That's what a METAR is for. A TAF is a forecast. It's a meteorologist's best prediction of the weather to come, usually within 5 nautical miles of an airport. And while it's designed for us pilots, it's also used by air traffic control to plan runways, by de-icing crews to get ready, and even by snow removal teams. It's a key operational tool for the entire airport.
So where do these things even come from? It's not just a computer spitting out data. Let's take a look at the anatomy of a TAF, and that starts with the people who actually write them. Now, this is actually pretty interesting. You might think each TAF is written by a forecaster at the local airport, but nope. In Canada, every single TAF is produced by certified meteorologists at just 2 centers, CMAC West in Edmonton and CMAC East in Montreal. The setup ensures you get consistency and real expertise, no matter which airport you're flying to. And just like a METAR, a TAF follows a very strict, consistent order. It's always going to start with the airport and the time, then move right into wind, visibility, weather, and clouds. Once you know this sequence, you always know where to find the info you need. And then at the end, you have the change groups, which tell us how the weather is going to evolve. We'll get to those in a bit. Okay, let's get into the real meat of the forecast, the core weather elements. This is the foundation for building that mental picture of the weather.
First up, wind. Now listen up, because this is a big one. The wind direction in a TAF is always given in degrees true, not magnetic, like you hear from the tower or on an ATIS. That's a crucial difference for flight planning. Speeds and knots, of course, and if you see a G, get ready for gusts that are at least 10 knots stronger than the steady wind.
Next up is visibility, which we measure in statute miles here in North America. You'll see fractions for lower vis, but once we get up to 3 miles, it switches to whole numbers. The code you're always hoping to see is P6SM. That means plus 6 statute miles. Basically, a beautiful clear day.
And here's your cheat sheet for clouds. It's all measured in eighths of the sky, or octas. Few and scattered are pretty self-explanatory. But remember, the moment you see broken, or BKN, or overcast, OVC, you're officially dealing with a ceiling. And if you see VV, that means the sky is totally obscured, and the number after it is your vertical visibility into something like fog or heavy snow. That's a definite instrument flying day. Okay, but weather rarely just sits still, right? It's always changing. And that's where the dynamic elements come in. The change groups are how forecasters tell us the story of how the weather is going to evolve.
And I love this slide because it illustrates the 2 types of permanent change perfectly. FM stands for from, and it means a rapid, significant change is happening, like a front moving through. Think of it like a hard cut in a movie. On the other hand, BECMG for becoming is a much more gradual change over a few hours, like a slow fade, as morning fog burns off.
Tempo is a different beast altogether. These are temporary changes. Think about things like scattered afternoon rain showers that pop up and then go away. The key rules are that these conditions are expected to last for less than an hour each time they occur, and in total, they won't be around for more than half of the tempo period.
And finally, we have probe. This is a special tool that forecasters only use for a 30% or 40% chance of something significant, like thunderstorms or freezing rain. It's their way of giving you a heads up. Now, what if the chance is 50% or higher? Well, then they won't use probe. They're confident enough to just put it in the forecast using tempo or FM.
All right, we've got all the pieces of the puzzle. It's time to go back to that monster TAF from the beginning and put our new skills to the test.
Let's translate it, line by line, into a plain English weather story.
So here it is again. It doesn't look quite so terrifying now, does it? You can already see the structure we talked about, the initial conditions, followed by a series of FM groups that are clearly telling a story about changing weather.
So let's start with the basics. It's a TAF for Ottawa, CYOW. It was issued on the 26th at 23:38 Zulu, and it's valid for a full 24 hours on the 27th. To kick things off, the weather is actually quite nice. Just light and variable winds, great visibility, and some high clouds. No problems there. And then, at 0300 Zulu, the story begins. We see our first change. The wind swings around to the east, and that high overcast layer starts to thicken up and lower down to a broken ceiling at 10,000 feet. For pilots in this part of the world, an easterly wind is often the first sign that a weather system is on its way. Now the story really picks up speed. At 1000 Z, the wind increases, light snow starts to fall, and that ceiling drops to 5,000 feet. Just 2 hours later, at 1200 Z, things deteriorate even more. The wind is a little stronger, visibility is now down to 2 miles in that snow, and the ceiling has come all the way down to 1,200 feet. We've officially gone from VFR to solid IFR conditions. And for the last part of the forecast, from 1800 to 2400 Zulu, the forecaster adds a little warning. There's a 30% chance of some light freezing drizzle and mist. That's a huge heads up about potential icing. The remark at the end? That's just administrative stuff, telling us when the next TAF is scheduled to come out.
So here's the real takeaway. It's not about just decoding each little group of letters and numbers. It's about looking for the trend. You have to build a mental movie of what the forecaster is trying to tell you. In this case, the story was crystal clear. A system was moving in from the east, bringing clouds, then snow, dropping ceilings and visibility, and ending with a risk of icing.
Reading a TAF isn't just a technical skill. It's about understanding the narrative of the sky. Now that you have the tools, you can look at any TAF and see not just the data, but the story that the forecaster is telling. Thanks for joining me.